All right, we're recording. It is Wednesday, 10/7. This is a recording of Algebra 1 and doing some single-step equations for one of my students, Jake. So here you go, Jake. You are looking at some homework, I think, from page 88, which has you solving one-step equations for when something is either being multiplied or divided. So, for example, if you have a problem like 13s equals 195, you have to get s by itself. You have to isolate s, so you have to undo whatever's happening to it. And since it says 13s, that means 13 is multiplying itself times s. So in order to undo the multiplication, you're going to divide by 13. Because 13 divided by 13, that becomes the big magic number 1, right? 13 divided by 13 is 1. And 1 times s is s. So then s is by itself. And just as you do anything on the left side of the equation, you have to do the same exact thing to the right side of the equation to keep it balanced. So we're going to go over and divide the 195 by 13. And 195 divided by 13, 13 goes into 19 once, and we have 6 left over, and 13 goes into 65 5 times. You could also use a calculator and figure that out. 195 divided by 13 is 15. So s equals 15. If you wanted to check your answer, you would substitute that value back into the original equation. So 13 times 15, does that equal, that's a question mark over an equals, does that equal 195? If we check it, 13 times 15, you could plug that in your calculator or do the math by hand. Yes, indeed, 195 does equal 195, so that checks. So if you want to undo multiplication, you need to do division. If you have a division problem, so sometimes division will look like a fraction. So something like, let's do t over 3 equals 9. So it's actually t divided by 3 equals 9 if we look at it that way. And in order to undo division, we do multiplication, that multiplicative inverse we're doing for division and multiplication. We're doing the reverse to undo it. So we multiply by 3, and sometimes students will write a 3 over a 1 just to show that it's fractional. It's an improper fraction, and you see the cross-canceling that'll happen with the 3's, and the 3's cancel out to become 1's, and you have 1 times 1 times 1 times 1, which is 1, and 1 times t is t. So if we multiplied by a 3 over 1 or a 3 on the left, we have to go over to the right and multiply by a 3 or a 3 over 1. So 9 times 3 is 27. So if we check it, t equals 27, we plug it back into the original equation. 27 over 3, does that equal 9? 27 divided by 3, yep, 9 equals 9, and it checks. We did it right. So if you see division, you do the multiplication. Now one step further is if you see a fraction next to a variable. So if you see something like 2 and 1/4 g equals 1/2. Well, the very first step you need to do is, when we have improper fractions in algebra, we don't like that. It's a mess. So always, mixed numbers. When we see mixed numbers in algebra, we don't like it. It's a mess. So we want to change our mixed number to an improper fraction. So 4 times 2 plus 1 is 9/4 g. Okay, 2 1/4 is the same as 9/4, right? If you had 2 whole pizzas divided up into 4 parts and 1/4 of a piece, you would have 9/4 total, right? 4 times 2 is 8 plus 1 is 9/4. So a little review of changing a mixed number to an improper. 9/4 g equals 1/2. Now, to undo 9/4 g, it's multiplying g. We would want to divide, and in dividing fractions is really multiplying by the reciprocal. Remember, you flip the second fraction. So if we multiplied by 4 over 9, notice that 4/9 times 9/4, everything cancels. The 4 cancels with the 4, the 9 cancels with the 9, and everything becomes 1. And 1 times 1 and 1 times 1 is 1, and 1 times g is g. So we got g by itself. And if we multiplied by the reciprocal 4/9 on the left, we have to go over and multiply by 4/9 on the right. Multiply by the exact same thing you multiplied on the left to keep it balanced. So 1/2 times 4/9, you can do some simplifying there if you would like, or you can just multiply straight across and simplify. 1 times 4 is 4, 2 times 9 is 18, and then you can put 2 into both of the 4 and the 18 and you get 2/9. Or we could have simplified and got 2/9. So g is 2/9. If you wanted to check your answer, you would plug it back in and say, does 9/4 times 2/9 equal 1/2? Well, 9 times 2 is 18. 4 times 9 is 36. Sure enough, 18 is half of 36. So we did it right. Okay? So if you have a fraction, change it to an improper if it's not already in simple form, and then multiply by the reciprocal. All right? So 3 scenarios in this section, Jake. You're going to have division where you, like number 1 is t over 7. I'll do that one with you, equals -5. Because it's division, t divided by 7 equals -5. To undo the division, you're going to multiply by 7 on both sides. So the 7's cancel to become 1's. You have a t left over on the left, and that equals -5 times 7, which is -35. If you check it, -35 divided by 7, does that equal -5? And sure enough, -35 divided by 7 is -5, isn't it? So we did it right. Number 3, I'll do number 3 with you on your homework. It has a fraction. It has 2/3 n equals 10. So in order to get rid of a 2/3 multiplying itself times 10, we need to do the division. But remember, in fractions, doing division is multiplying by the reciprocal. So we're going to multiply by 3/2 to cancel those out. So we're going to go over on the right-hand side and also multiply by the same thing, 3/2. So they cancel on the left, and we get 1 times 1 times 1 times 1, right, is n. And then 10 times 3/2. So put your 10 over a 1. And you can either simplify the 2 and the 10 if you want to, or you can multiply straight across and simplify it afterwards. 10 times 3 is 30. 1 times 2 is 2. 30 divided by 2, and your answer is 15. If you wanted to check it, 2/3 times 15, does that equal 10? We'll put your 15 over 1. 2 times 15 is 30. 3 times 1 is 3. 30 over 3, yep, that's 10. It checks. Okay? So there's a fraction that you have to undo next to a variable. And then finally, just working on like number 8, if you jump all the way down to number 8, you have 8t equals 72. 8t equals 72. The 8 is multiplying itself times t. It's not a fraction, so we're just going to do the division, divide by 8, which is really multiplying by 1/8, isn't it? Which is still reciprocal. But we just like to draw a line and divide by 8. We show that those cancel. We divide by 8 on the other side of the equation, the right side of the equation. 72 divided by 8 is 9, so t equals 9. If we check it, does 8 times 9 equal 72? Sure enough, 8 times 9 is 72. 72 equals 72, and they check. So there's the different styles of problems that you'll see in that homework on page 88. All right, maybe let's do one more. Let's do a mixed number again. I'll jump all the way down to number 20. All right, number 20 says 4 1/5 equals 3p. So because we have a mixed number, you want to change it to an improper to work with it. Don't try to work with it as a mixed number. We don't like those in algebra until the very end. So change this to an improper. 5 times 4 plus 1 gives us 21/5, right? Because if we had 4 pizzas cut into 5 parts each, we'd have 20 pieces, and then we have this one little fifth of a piece there, so we have a total of 21/5 equals 3p. Now we're going to divide by 3 on both sides, right? So if we divide 21/5 by 3, actually we're multiplying it by 1 over 3, aren't we? Because dividing by 3, when you do fractions, you have to flip it, don't you? And that would be 3 over 1, so we're going to flip it to 1/3. So 1/3 times 21 over 5, we could do the canceling, the simplifying, the 3 and the 21 simplify to a 1 and a 7, and we're end up with 7/5 equals P. And if we wanted to check it, we could say, well, does 3 times 7/5 equal our 21/5? And sure enough, 3 times 7 is 21 over 5 is 21/5. And then we do the division again. 5 goes into 21 4 times, remainder 1. That's back to our original 4 and 1/5. So that was a little tricky one, and then that you had to realize when you divide by the 3 next to the P, if you're dividing a fraction, you have to flip it. So dividing by 3 means multiplying by 1/3. So that'll help you with number 20 and any problems that kind of look like that. And remember, always change your mixed numbers to impropers. So I think that'll cover the problems that you're going to need to do in this section, Jake. You can always just kind of watch it over and over again in different parts to help you out as you need be, or pause it, and hopefully that gets you through the homework. If you need any more help, email or call me, and I can help you out or make another video. Take care. We'll see you soon.